Fluids.
At night.
So to find out what type of flow the fluid has, you start using Reynolds number. That means you can use the density times the velocity times the length of the tube over the viscosity. So the numerator is just describing the flow of the fluid itself. The denominator is talking about the viscosity of the fluid. So if you want to find out whether it's laminar or turbulent, if you have a higher viscosity, you're going to have a lower Reynolds number because it's in the denominator, which means that you have a more laminar flow. If you have a greater velocity, or like the size of the amount of fluid going through the tube, you have a higher Reynolds number, which means that it's more turbulent. And you can change any type of flow by changing any of the numbers that you put in here, so any characteristic of the fluid. So we did out the math for Reynolds number, and as you can see, all the units end up canceling out, which means that the number itself is unitless.
There are three types of flow: laminar, transitional, and turbulent. Laminar can be described as straight, steady, and smooth. Transitional is somewhere in between turbulent and laminar, and turbulent flow is unsteady, random, and unpredictable. This can be thought of as like water through a garden hose. So laminar flow would be straight flow, just looks glassy and straight. If you put your thumb over it, it'll make a sheet of water that comes out sort of straight. And then turbulent would be like if there wasn't enough flow for a steady flow and it just sort of comes out in a random pattern. Okay, so this bad boy right here, you see that? This bad boy is going to show us some turbulent flow. Those water vectors are going to be all over the place. Eureka!
We used the same cups and the same water for both experiments, but because this one has a smaller hole and what we used as a smooth pipe, or just a straw in this case, this one was able to have more time for the water vectors as they went through to organize because they're all being pushed in the same direction at the same speed. So the water came out in more of a laminar flow than turbulent, like when Zach did it.
Whoa! That's pretty neat.
Okay, so in that case, the water flowing didn't really have anything to do with the variables once it was out of the straw. So you could see at the very beginning, right when it was coming out of the straw, it looked laminar, it was smooth, but over time as it started to get closer to the bucket at the bottom, it became a lot more turbulent because it no longer had that straw or really anything else to contain it and keep all the vectors going in the same direction. So it could become more random.
Whoa. That's pretty straight. Yeah. Look at that.
So, in the case with the honey, the main factor as to why it had a laminar flow as opposed to turbulent has to do with the viscosity of the honey rather than the container that it was flowing out of. And like we said earlier, if it has a higher viscosity, it's more likely to have a laminar flow, which was an easy way to demonstrate it with a different